Bah. Turns out, speech in noise and brain aging. Your brain might be shrinking right now, and it has nothing to do with how well you can hear your friends across the dinner table. Or at least that's what we thought. But a new study from Australia suggests that your ability to pick out speech in a noisy room, that one skill you didn't even know you had, might be intimately connected to how fast your brain ages. And here's the really weird part. Having normal hearing thresholds doesn't protect you. You could pass a standard hearing test with flying colours and still have this hidden vulnerability. So what exactly is this skill? Why does your brain care about it? And what does it mean if you're struggling to hear people at that coffee shop? We've known for years that hearing loss and dementia are connected. It's one of the most robust findings in neuroscience. Older adults with untreated hearing loss have higher rates of cognitive decline, memory problems, and actual dementia diagnosis. The theories are intuitive enough. Your brain has to work harder to understand garbled speech, which drains cognitive resources, which eventually leaves less energy for other mental tasks. But here's the thing nobody has really nailed down. Is it the hearing loss itself that matters, or is it specifically your ability to process speech in messy, noisy environments? And more importantly, can a hearing aid actually slow down that brain shrinkage? That's what researchers wanted to know. Zanin, McNeil, and Rance at the University of Melbourne set out to answer this. Rance runs the audiology and speech pathology department there, a team that's spent decades studying how the brain's hearing networks function. The work was published in May 2026 in JAMA Otolaryngology, which is about as prestigious as it gets for hearing research. What makes this study special isn't just the question, it's the data. We're talking about structural brain imaging combined with detailed hearing tests followed over 3 years. The researchers started with older adults from the Aspire trial, a massive Australian study that's been tracking community-dwelling seniors for years. Some had normal hearing. Some had hearing loss but weren't wearing aids. Some were wearing hearing aids. They gave everyone 3 things. First, a standard audiogram, the usual hearing test where you raise your hand when you hear a beep. Second, a speech in noise test, where you listen to sentences buried in background babble and have to repeat them back. This is the key exposure. It's way harder than a pure tone hearing test because it requires your brain to do something called listening effort, actively filtering out the noise and extracting the signal. Third, they scanned everyone's brains with MRI at the start, and again 3 years later, measuring cortical thickness in speech processing regions. They also tracked cognitive outcomes. Then they looked at which hearing measure, standard thresholds, speech in noise ability, or hearing aid use, best predicted how much people's brains actually shrank. Think of it like this. Imagine you're trying to find your friend in a crowded bar. If you have perfect hearing but your brain's filtering system is sluggish, you'll struggle. Conversely, you might have slightly weaker hearing but a superb ability to filter and focus. The bar test is your speech in noise ability. It tells you something about your brain's real-world listening capacity that a quiet room hearing test just can't capture. That's essentially what these researchers measured, and then they watched what happened to the brain tissue itself. Here's what they found. Baseline hearing thresholds, the standard audiogram results, didn't predict cortical atrophy. You could have mild hearing loss and not be at elevated risk, but speech in noise ability did predict it. People who struggled to understand speech in noise showed more thinning in their cortex over the 3-year period, specifically in regions known to process speech and integrate it with language and meaning. The effect wasn't tiny either. Worse speech in noise scores were associated with measurable, progressive cortical loss in the superior temporal gyrus and parts of the language network. And here's the clincher. Hearing aid users showed significantly less cortical thinning compared to people with untreated hearing loss, even when their baseline hearing thresholds were similar. So the aid itself seemed to protect against brain aging, at least in those speech processing regions. The cognitive outcomes followed suit. People with poor speech in noise ability and untreated hearing loss showed steeper cognitive decline. But hearing aid users, even those with objectively the same degree of hearing loss, didn't show that accelerated decline. It's as if the hearing aid reduced the cognitive burden of listening, which allowed the brain to preserve its tissue and continue functioning normally. The magnitudes here matter. We're talking about measurable cortical thinning in the range of millimeters and cognitive effects that accumulated meaningfully over just 3 years. The implications are genuinely practical. If you're over 60 and you're noticing yourself turning up the TV or asking people to repeat themselves, this study suggests you shouldn't just wait for a catastrophic hearing loss diagnosis. You should specifically get tested on your ability to understand speech in noise, because that seems to be the metric that correlates with your brain's aging trajectory. More radically, it suggests that a hearing aid isn't a passive prosthetic device. It might actively slow neurodegeneration. But there are honest limitations here. The study is observational, not randomized. Maybe people who use hearing aids are more health conscious in other ways. The sample wasn't enormous, and we're still not entirely sure about the direction of causality. Does poor speech in noise ability cause cortical thinning, or does early cortical thinning cause poor speech in noise ability? Probably both, but the study can't definitively prove the causal chain. This research sits in this interesting gap between audiology and neurology that's still pretty underexplored. We know hearing loss is a dementia risk factor, but we've mostly been treating it as a peripheral problem. Fix the ears, fix the brain. This suggests it's actually a network problem. The brain's ability to extract meaning from degraded signals is what matters. That points toward future research directions that are pretty exciting. Do other sensory processing deficits, vision in noise for instance, show the same pattern? Can we predict dementia risk more accurately using speech in noise testing combined with brain imaging? Should hearing aid fitting protocols be optimized specifically to reduce listening effort rather than just restore hearing? These questions are already being pursued, but this study gives them momentum. Turns out, your brain's relationship with sound isn't as simple as we thought. It's not about having perfect hearing. It's about your brain's ability to work intelligently with imperfect information, to filter and focus in a noisy world. And when that ability degrades, for whatever reason, your brain tissue starts to thin. But here's the hopeful part. We might have a tool that reverses that. A hearing aid, which raises a final question worth sitting with. If we could identify people at risk of this cortical decline, and we gave them hearing aids before significant damage happened, how much cognitive decline could we actually prevent? Scientists have been busy, and they're not done yet.